Tonight, if you look toward Orion, you can find one of the most famous stars in the night sky. It glows with a distinctive reddish color on the shoulder of the hunter. Its name is Betelgeuse. For centuries, humans have watched this enormous star without knowing just how strange it really is. But astronomers now have a much clearer picture. Betelgeuse is not simply a giant star slowly approaching the end of its life. Evidence indicates that it has a companion. A second star orbiting the enormous red supergiant and disturbing its outer atmosphere. And that discovery could change the way scientists understand the final stages of massive stars. Betelgeuse is classified as a red supergiant, one of the largest types of stars known. It is so enormous that if it replaced our Sun, its outer atmosphere would extend far into the region of the inner solar system. The comparison with Earth is almost impossible to imagine. Our Sun is roughly 1.4 million kilometers across. Betelgeuse is hundreds of times wider. Yet despite its incredible size, the star is nearing the end of its stellar evolution. Massive stars begin their lives by fusing hydrogen in their cores. For millions of years, that nuclear fusion produces the energy that prevents gravity from crushing the star inward. Eventually, however, the hydrogen in the core becomes depleted. The core contracts. The temperature rises. The star begins burning heavier elements. Its outer layers expand dramatically. The result is a red supergiant. And eventually, depending on its mass and internal evolution, the core can collapse and produce a supernova. That part of Betelgeuse's story has been known for decades. But there was always something strange about the star. Betelgeuse does not shine with perfectly steady brightness. It naturally expands and contracts. Its atmosphere rises and falls. Massive amounts of material are thrown into space. And its brightness changes on several different timescales. One of the most puzzling variations occurs over a period of roughly 6 years. For a long time, astronomers struggled to explain exactly what was producing that long cycle. Then came an extraordinary possibility. What if Betelgeuse wasn't alone? Instead of being caused entirely by the star itself, what if part of the pattern was being created by another object orbiting the red supergiant? That idea became increasingly interesting as astronomers studied years of observations. And the possible companion is remarkably different from Betelgeuse. Rather than another enormous red supergiant, it appears to be a much smaller, hotter star. The companion would orbit Betelgeuse at a distance comparable to several astronomical units. But because Betelgeuse is so enormous, that distance may place the companion within the star's extended outer atmosphere. Imagine a smaller star moving through the enormous envelope of a dying giant. As it travels, its gravity disturbs the surrounding gas. It creates a wake. Just like a boat moving through water leaves disturbed water behind it, the companion can leave a trail of disturbed stellar material. That trail can alter the movement of gas surrounding Betelgeuse. And that disturbance can become visible in the light we receive from the system. This is where spectroscopy becomes incredibly important. Astronomers don't just photograph distant stars. They can split their light into a spectrum. Inside that spectrum are fingerprints produced by different chemical elements. And when the gas moves toward or away from us, those fingerprints shift. By measuring those tiny changes, scientists can reconstruct how material in a star's atmosphere is moving. If the same disturbance appears again and again according to a predictable schedule, it can reveal the presence of an unseen companion. That is exactly what makes the Betelgeuse system so fascinating. The suspected companion appears to follow a roughly 6-year orbital cycle. As it moves through the extended atmosphere of Betelgeuse, it can disturb the surrounding gas. That disturbance produces a repeating pattern. And the pattern provides astronomers with a way to track something they cannot easily see directly. The discovery is important for another reason. For years, Betelgeuse's dramatic dimming in 2019 and 2020 created enormous excitement. The star became noticeably fainter. People around the world wondered whether this enormous red supergiant was finally about to explode. But astronomers eventually determined that the dimming was caused primarily by material expelled from the star that cooled and formed dust, temporarily blocking some of its light. It was an extraordinary event. But it was not the supernova. Betelgeuse survived. And that episode taught scientists something important. Massive red supergiants can undergo enormous changes without immediately reaching the final moment of their lives. The discovery of a companion adds another piece to that puzzle. A nearby star could influence the outer atmosphere. It could affect how material is expelled. It could alter the movement of gas around Betelgeuse. And over extremely long periods of time, gravitational interaction between the two stars could reshape the entire system. This is why studying Betelgeuse is about much more than one famous star. Massive stars are responsible for creating and distributing many of the elements that eventually become planets, moons, and living worlds. When a massive star dies, its final stages can dramatically enrich the surrounding space. The material released by such stars can eventually become part of new generations of stars and planets. Understanding how these stars lose mass before their deaths is therefore essential to understanding the evolution of galaxies themselves. And Betelgeuse gives astronomers something incredibly valuable: a nearby laboratory. The star is hundreds of light-years away, which sounds impossibly distant. But compared with most stars in the universe, Betelgeuse is relatively close. That makes it one of the best opportunities we have to study a red supergiant in detail. Astronomers can monitor its brightness. They can analyze its atmosphere. They can track its changing surface. They can study the material it throws into space. And now, they may also be able to study how a companion interacts with that enormous atmosphere. But there is an important misconception to clear up. The discovery of a companion does not mean Betelgeuse is about to explode. In fact, the evidence points toward a much longer timeline. The star is still evolving. Its eventual supernova could be thousands, tens of thousands, or even longer into the future. In other words, nobody should expect Betelgeuse to explode next week, next year, or even within a human lifetime simply because it has a companion. The universe operates on timescales that are almost impossible for humans to comprehend. Betelgeuse has been evolving for millions of years. Its final explosion will happen when the physics inside its core reaches the point where gravity can no longer be resisted. When that moment eventually arrives, the collapse will happen extraordinarily quickly. The core will fall inward. The outer layers will respond. And an enormous explosion will send material racing into space. From Earth, the event would be spectacular. Betelgeuse is close enough that a supernova could become extraordinarily bright in our sky. But it would not destroy Earth. The distance is far too great for that. Instead, humanity would witness one of nature's greatest astronomical events. A star that humans have watched for thousands of years would suddenly transform. The familiar red point in Orion would become dramatically brighter. And for a brief period, an ancient star would dominate the night sky. But that day is almost certainly not coming anytime soon. For now, the real story is even more interesting. We are watching the star before the explosion. We are studying its atmosphere. We are watching it lose material. We are measuring its pulsations.